Hello everyone. Today I will show you how I assemble my upgrade 3018 Pro Max CNC, and I name it 3018 Deluxe. I like the way they designed the Pro Max. I mean, look for the Z-axis. It is aluminum. It's give me the chance to change it and make it more stronger and more strength and more stable. So I changed the rods from 12 to 16, and I changed the ball screw. The idea is changing the rods. It's make it more stable, also for the y-axis as well. I'm not willing to show the lathe work because everybody has got his own way to upgrade his machine. So I'm sharing this video. Might you have some idea, how the way I upgrade it, and might help you in some way or another. Without further ado, let us check how the way I assemble. All right, let me start with testing the limit switches. Simply, I make it from old antenna. I make it like a small pipe, and then I use the macro. I don't know if you can see it. This is the macro. It is macro switch, usually open. I will test it. See, this is the down one. Now the upper one. So there is up and down. Limit switches is important. Usually the small CNC, they don't they just don't give attention to it, because just small, they say, well, what's worse gonna be happen? But this is not the idea. The idea is you want to learn how to deal with CNC, regardless is small or big. Anyway, remove the wire. Meter. Now I will talk about this rod. There is the original rod, and there is the one I made from stainless steel. I will discover that. See this? This is comes with the CNC. Right. What I see is why the people complain about vibrating is this size. It is 7.93. Now the one I made, it is stainless steel, 7.99. Small numbers can make a huge difference. That's what it is. So if you witness vibrating, this is the solution for it, is to change the rod. See? See that? Stainless steel never get rust. When you are cutting aluminium, you need the cold water. This will never get rusty, right? You see that? Small ball rate screw, 8 mm the thickness. Is, you know, it's very difficult to find this one. I find it in on eBay. Anyway, it's not coming with a ball bearing in the top, and I add a ring over here. So I'll try to assemble it now. By the way, I put small screw here. Small screw here, so it's not let the ball bearing fall down. See that? Okay. Don't tighten it. Let's bring it down to do the balance. Okay, now it's working, folks. Okay, let us review what we have been done. We put the stepper motor mount coupler inside, and we do the limit switches, and we pour the aluminium and do the lathe work here as well as there. Let us check about the compact liner ball bearing 24, and from inside you could see 16. So that was the original one for the the x-axis. You could see that. You could see that. Now that one does not catch, and we'll see, just to test before we fix. This is 16, that is 16, and let us check. The ball, the lead screw, ball lead screw, how it's going to be. It's going to be like that. So this is the Z-axis now, complete. With limit switches. .1 stepper motor amps. The amps is 2.1 for that. It's and also you could see it is almost 6 centimeter. Okay, now we will start to assemble the y-axis. There is something will slow me down, which is I use it for the screw. I think the GRBL, it will be nice when I do the screwing. Okay, before we start, I say why if I do the Z-axis with a compact liner ball bearing, so why not I'm doing the same and put also the ball screw, the ball lead screw with y-axis as well. Anyway, I have to change something, of course, for the lead screw. So this is the original one, and to make another one for the lead screw, what I did is I brought the block aluminum and I cut it into half like this. It was like that, and then I cut it, and then I put small piece of aluminum as well, but the thickness was 10 mm, so I shave it and file it up to come like 9 mm to match the center. You know, this is the center, so the center must be exact the same. So the center here is matching that one as well. Okay, and about the compact liner ball bearing. I just do the same for the Z-axis. You could see now by the lathe work, of course. It is it's 24. It's 24. Right, before the hole was 21, so by the lathe it's become a little bit thin, but it's okay, you know. And you could see the old one, old rod. It is 12. It's 93. That's 12 almost, right? And then you could see if you are using the coolant as water, it will get rusty because, you know, see, it's touching the magnet. Now the new rod, I'm using that one, stainless steel. Measurement is 16. You could see that, 16. Smooth. So one thing I want to tell about also the mount, stable motor. Now if you're using the y-axis to put the mount, you don't put it in this position, because you know the chips can go inside. So either you do it at the corner side here or there, or you might do it for small CNC, you can do it at the down if you like, because easy you can carry. But for the heavy one or big one, you can do it at that side, or depends what you like, here or there, right? But never put it in the top, so it's not collecting any chip here to go through, right? So just like this. Now we start to assemble. Let us remove what we have here. You can see it's already ready, the holes for the x-axis. Like this. You know, folks, it will take time, so I try to cut up the video to make it short, but slowly it's so that you can see how the way I assemble this one. I take some shots only. By the way, this aluminum glue or weld, it will take 48. Why I'm using it? It is good for the thread, especially if there is any gap between the thread. It will just hold it nice, and you can open it in the future if you like, no problem. I mean the screws, but you know, it's holding the strength of the. It's good for the screws, especially. I'll show you, for example, if I take one of the rods, sorry, not that one, this is different size. Let us check here. You can see it's a little bit shaking, so the glues make it steady after that. Something I have to show you guys before I put the rod. I see something, you know, unpleasant. You see, there is a gap. Now this is the original one. I measure it is 1 milli because I cut this one the same as the size of that one, so it will be the same. And if I tighten it, it will bend, you know, it will bend for like 1 milli. Anyway, I bring washer. The thickness is almost 1 milli, and let me try it. This is the spacer. Yeah. Now we are talking. And this way, it's nice now. Okay, folks, now I'm trying to adjust, so you have to bring it to the edges where the board line over here, so you can adjust, otherwise it will be played. And make sure it's in the middle here. I did not tighten it up yet, but right now I think it's okay to tighten. Okay, let us do some test. So I can scroll it from the motor, or simply can go also over here. See? So this is the ball lead screw and 16 mm liners. Folks, I think it's rigid more than ever. That's what I'm thinking. I should continue to X-axis then. Okay, now we are ready to fix the X-axis. The X-axis is a lot of screws. I calculate almost like I'm dealing with 50. So I'm not taking the video for all what I'm doing. But anyway, shot from here and there. We got the acrylic. I don't know what they call it. It is the acrylic fins, or maybe wings, or maybe we just call it a collector, chip collector. I don't know. Anyway, let's move this away. I need this. Really, it's helpful and give the strength for the screws. By the way, I going to put the motor on the left side, because here is where holding the lead screw. That's one of the changing. So everything now is loose. I just put the screws just like that. Not yet I tighten it up. Okay. That's the axis. check. Okay, better put the lead screw first also. Very smooth. Okay, I done from the x-axis and it's working now smoothly, and the y-axis very smooth as well and strong. The z-axis, all of them is bolt screws, plus the rods here it's 1616 stainless steel. Cannot do this upgrade without lathe. The next video or the next episode is going to be about the controlling or the control box for that, and some limit switches over here and there. We finished from the limited switch in the Z-axis. That's it, folks. Thank you.